Welcome back. This is lecture two in week three of the course Data Visualization, Data 205N. We're going to continue with our discussion about images in the head. I'm going to just pick up where I left off in the last session. For that, I need to run down here. And if you remember what we were doing last time was we were talking about the data ink ratio and how by increasing the data to ink ratio, or effectively increasing the data or reducing the ink, taking out any clutter, it declutters charts and it makes them more readable. So here's an example of a chart that you might put up. They've done several things. I don't know what Klaus Wilke would label this one, but it has room for improvement. Let's just say that. And here's how we clean that up. We did a series of pretty subtle things, right? First of all, we took off these horizontal grid lines because they really weren't meaningful. I can read across here. I can see what those are. The second is that I took this annotation off of there because when I took off the grid lines, I could directly label the line. So I could just put the label right directly on this line. And then the third thing I did was I separated spring and fall semesters. So you notice over here I have spring and then I have fall and spring and then fall. Well, there's no reason to do that. In fact, I would probably tend to do these as dodged bars, which means I put the light blue and the dark blue kind of right next to each other, and then the dark blue and the light blue kind of right next to each other. And so I kind of group these together closer. Um, and I left everything else the same, but pretty subtle changes that made a pretty dramatic improvement in the chart. So this is the idea of just taking chart clutter off. Now, when you're putting up tables, there are some suggestions for text alignment that just make it a huge amount more readable. If you have numerical values in a table, they should usually be right aligned. They don't have to be, but they should usually be. All the columns showing a value should include the same number of decimal digits. So you don't want to have a column that has, 2.54 and another column that has 2.54718,316. So whatever the right number of decimals is, be consistent with that. You only want to include the necessary number of digits. And so too often I see charts that, show you numbers to three decimal places when it's meaninless. So actually think hard about how many digits you're going to show. And you might think that, well, if I showed it two or three digits, I'm implying more accuracy. But that's the problem. You're implying more accuracy that might not be true in the data. Like if that's an average, it's true. That is the average, but how is that meaningful? I mean, it just knowing whether the average is 3.214 or 3 or 3.2 as an example, is usually not meaningful. Any additional digits increase the clutter in the chart. If you have very large numbers, you want to display rounded to the nearest 100,000, 10,000 million. So rather than showing 10,256,169, you should be saying, 10 million and 9 million, 8 million, that sort of thing. You should round those. And in general, it's most effective to left align text values within a column in a table. Now, there's an interesting thing having to do with eye travel, and it has to do with how somebody first encounters a table, or well, not just a table, any visualization, and any eye travel is increasing cognitive load. Again, we're trying to reduce cognitive load, and so we want to try to minimize the eye travel. I'll just go back here for a minute and show you an example of that. Actually, I think I got one down here. Sorry. I'll show you one in just a minute. So. We can do that. We can minimize that by using pre-attentive attributes, by using Gestalt principles, by increasing the data ink ratio, and therefore we're going to minimize eye travel. So, oh, here's a good example. So here's a default line chart that I might have gotten out of Excel. And so the dashed line is the District 2, the solid line is District 1. This is property crime rate in Spring Field. We're missing an F here for some reason. And this is the proportion of closed cases, and this is the month. So we've got a time series across here. So we drew this as a line chart, and we've got two different districts. So a really simple change to that, take this legend off, this District 1, District 2, and direct label these lines. It actually makes a huge difference. And here's why. When I first look at this chart, I see these two lines, and then I have to say, well, what do these lines mean? Then my eye has to go down here and I say, okay, the solid line is District 1. So I come back up here and say, okay, that's District 1. Okay, the dashed line is District 2, and that come back. If I don't have to do that, if I can just look at this chart and say, okay, that's District 1, that I've minimized the eye travel, and that's a good thing. We're trying to do that. So I lined, let's see, I did a couple things. I did another thing. Yeah, so I did another thing. I took proportion close with arrest. I took that off this horizontal uh, y-axis. I'm sorry, this vertical y-axis, because this text is hard to read. I don't know about you, but I have to kind of turn my head to read that. That's hard to read. Whenever you put up text that's not horizontally aligned, or sorry, horizontally formatted, it's hard to read. So all we did was we moved that text over here. It meant the same thing. You know, you still understood that, right? So we moved this proportion up here with the title. We moved the line labels so they were over here. Uh, okay, so there's an exercise in the textbook for how to do this. This is worthwhile if you're not familiar with how to label these lines like this to follow that. I'm not going to do that in this lecture. I recommend you do. Again, you can go to in the textbook, section 3.4, you can find the data values for this, and it in very explicit detail, the textbook tells you how to go about doing what this chart to this chart does. So this is the default chart that you get if you just click and say, give me a line chart. This is the improved chart after we've done a couple things. We've moved this guy and we've directly labeled these. And that's an exercise in Module 3. So uh, this week, you have an exercise in doing that. Just a little bit on font size. Uh, well, there's a couple things. A serif font is usually preferred for printed work, and it includes end of stroke features. That's what the serifs are. These little it's this little sort of extension on the R and on the feet of the R. Those are serifs. And a serif font is usually preferred when we're printing because we have a highly defined sense of printed work, looking at printed work because we've been doing this for hundreds of years. Um, it's less legible at small sizes. So if you know your visualization is going to be reduced to small sizes, it's less legible, so you want to avoid that. And common serif fonts are things like Times New Roman, Courier. Those are common serif fonts. Sans serif, sans without, that means there's no serifs. Sort of obvious. And so here's an F without the serifs or an R without the serifs, and it's very much preferred in data visualization. The reason is because it works better in small sizes. It works better when it's not printed and you don't know. You might do some visualization that's highly successful, and you think you're just doing it for visualization for looking at it on a screen, and it makes it into print publication. So common fonts are Arial. We're probably real familiar with that. Calibri, a few others. Okay, so choosing fonts. It actually, believe it or not, fonts matter. Um, so the biggest thing is you should be consistent in your choice of fonts. In general, every font you have on a diagram should be the same. You could use different ones, but you have to ask yourself, why am I doing this? You might have a good reason, but you better have a good reason to do it. Um, when you use a consistent font, it reduces the cognitive load. Um, Horizontal and vertical axis titles should have the same font type and size. So I shouldn't reduce or expand the size of one and not do the same to the other. We want this to be symmetrical and pleasing. We're going to talk about a visualization eye here in a minute. And the use of different font sizes, bold, italic, color, all those sort of things, differentiate between features and they direct your audience attention. But you should really uh, choose and use these very carefully. In general, all the fonts should be the same size, the same, boldness and all that stuff. And only when you really want to highlight something, like particularly with bold or italic or color, do you go do that. It's pretty rare that a good visualization uses color in the fonts. They can, but it's pretty rare that they do it. And you might do it where you're trying to match a data item to a particular color. But other than that, it's pretty rare to do it. You can use bold and italic, but beyond that, you don't usually do that. Okay, so here's the wrong type of visualization. A clustered column chart. This is booked revenue uh, data. So this is booked revenue. We've got, this is quarters, quarter one, two, three, four, five, six. And we've got three areas, Hartford, Stanford, and Providence. And our goal is 600,000. So this is one way I could do this. This is a group bar or a Dodge bar chart. And I see that, I can compare the three. So this is mildly effective. It's not terrible. In fact, we've come to this place in other charts where we said we didn't like, I think we had a pie chart and we didn't like that, and so we put this up. Here's an improved chart. So we didn't have a background grid we had to get rid of. But what we did was we put a border around this, and then we turned all these into line charts because what I'm probably trying to do is understand trends. Now, I might want to compare the different regions, but I can do that actually more readily in a line chart than I can in a bar chart. So this line chart works better for this. I personally don't think that the shades of blue here work very effectively because they're not different enough. And it might just be an artifact of the way my screen displays, but I wouldn't choose necessarily a different primary color, but I would make the shadings a little more distinct because this line and this line, when they cross, they kind of wash together and it's hard to tell where one goes into the other. And yeah, if you study this for a little while, you understand what's going on. But I don't want to have to make my readers study it. I want them to get that like right now. Um, so the authors claim this chart is displaying excessive information. This is Keelan sales, and it's talking about OEM sales and aftermarket sales. And uh, I actually don't agree with this, and I've realized why I don't agree with them on this, and it's because I have seen Dodge bar charts or side-by-side bar charts like this a million times. And so it's very easy for me to see that the trend of the red one is like this and the trend of the blue one is like this. Not everybody's like that because not everybody has seen as many side-by-side bar charts as I have. I'm not boasting. I'm just saying that, my eye is highly trained to seeing this kind of a chart. Your eye may or may not be, but you got to think about your users and decide whether they're going to be highly trained or not. So what they're suggesting to do instead is one of two things. If what you're trying to do is you're really trying to show the total sales, then yeah, of course, this is wrong because if I wanted to understand total sales, I'd have to stack this orange bar on top of the blue bar. So that was really displaying excessive information when what I really wanted to talk about was total sales. And here's the components of them. It's this part's aftermarket and this part's OEM. So a stacked clustered column chart would work best if that's what I'm trying to do. If that's the task that I'm trying to have my user undertake, my reader undertake. The alternative to that is put it up as two charts. There's nothing wrong with putting up two charts. Sometimes you're space constrained, but maybe you just do it as two charts, particularly because the scales on these are different. And so, this is going up to 100, this is going up to 140. That's a little misleading, right? Because you could look at these two charts and you could say, as an example, you say, well, that bar is about the same height as this bar, but this chart is actually not going as high as that one. So this is a little misleading. That's why I don't show them side by side. I show them top to bottom so that I kind of try to resist the reader's desire to compare the sizes of these. The alternative would be to make this chart go to 140, and then this would and make the size of this, the physical size from 0 to 140, whatever that is, it's about 2 inches. Make that 2 inches here so that these read the same, and then I could make that distinction. Okay, so here's a column chart on annual revenue. That this is like the default that I got out of Excel. I wouldn't have gotten this. I had to put that in, but everything else I would have gotten out of Excel. I actually got the legend down here, and I probably moved it up here or something like that. That's the default that I got. Here's how to improve that. Now the first thing is that, this is just in what order the data was, whatever order the data was, and that's not usually how people want to evaluate things. The task that I want my reader to understand is how the regions compare to each other. Yes, I can do that here, but also who's the biggest and who's the smallest, who's leading and who's not. And I see from this one that Dallas is leading and Tyler is not. I also want to highlight Laredo. I'm not sure why, but I want to highlight Laredo. So it's comparing Laredo to other locations. Maybe I'm talking to the sales manager of Laredo. And so I'm going to highlight his region and say, by the way, you're not very far from Dallas and you're way ahead of your other competing regions. Now, this chart on the left is one where they're trying to do too much. So they're just trying to accomplish too many things. Excuse me, they've used pre-attentive attributes, they've used some Gestalt principles, I think. Excuse me. Excuse me. Um, to try to communicate too much. So they're trying to communicate years at the company versus billable hours. They're also trying to show whether it's a junior consultant, a senior consultant, or a partner, and they're doing that with colors. And then they're also trying to show the highest degree, and they're using shape to depict the highest degree. This is cognitive overload. This is just, excuse me, asking too much of the user. Yeah, if I sat here and studied this for a while, I could make sense of it. I could see that we have one uh, uh, employee who has been with the company 8 years and has a PhD, and his billable hours are the highest across the company. But this is just trying to do too much. So instead, what the author suggests is you take that out. You take the highest degree out. If you want to show that, put that on a separate chart. And so now I just have the junior, the senior, and the partner color coded. So really, I just have three attributes that I'm showing here, right? I'm showing years at company, excuse me, billable hours, and then I'm color coding the dots according to the consultant. Now, you might say, well, you could go to a bubble chart, right? And you could make the bubbles the highest degree. You could. I'm not a big fan of bubble charts. I've warned you before, I would stay away from 3D. It's really easy to produce 3D charts in Excel to your detriment. Don't mark yourself as a dinosaur and don't use 3D. Here's a better way to communicate that. It's more effective. User user get this right away, pre-attentively, and they don't have to sort through all this, fancy looking 3D stuff. Okay, let's switch to this idea of developing a visualization eye. This is out of Klaus Wilke, The Fundamentals of Data Visualization. And it- this is the idea of you can look at a figure and you can see whether it's balanced, it's clear and compelling. So having an eye means primarily that you're aware of a larger collection of simple rules and principles for good visualization, and that you pay attention to the little details that other people might not. And that's a lot of what we do in teaching visualization is pay attention to the little details because the little details actually matter. So Klaus Wilke uses this convention. If there's a chart that he doesn't like because it's just ugly, he'll label as ugly. If a chart that is wrong or is wrong, he'll label it as wrong. If it's just bad, it's just done poorly, he'll label it as bad. And he doesn't label things that he thinks are, I don't think he goes as far as saying good, but he doesn't label things that he doesn't think are any of these ugly, wrong, or bad. And it's a pretty effective technique. If you go through that textbook, you'll see all kinds of visualizations, some of which he labels as bad, some of which he doesn't, and you get a sense of why. And so, when we talk about a visual eye, um, except for the wrong one, I'll talk about that in a minute. I hope that you can see immediately why this one's ugly. I call this a gratuitous use of color, a GRUC. Gratuitous use of color. There's no reason to make these colors. Well, because they want to distinguish them, but they should have just labeled them down here. This is bad because we're putting the labels. Oh no, it's even worse. We're putting the labels right on the chart, and this C has a different axis than this C. So you notice 4 is higher than this. So this is incredibly misleading because when I look at this, I pre-attentively look at this and say, uh, this one's bigger than that one, which it is, but I don't have the same axis here. And so it's unbelievably misleading to do something like this. This is wrong because for the same reason. We haven't labeled the axes, but it's wrong for the same reason. If you think of this as the same data, it's wrong for the same reason. We actually didn't start the vertical axis at 0. We started it somewhere lower than that, somewhere about right there. And so it overemphasizes the differences in these, which is not really true. If you look at these three versus these three, you'll come away saying, you get the right order, right? This one's the biggest, that one's the next biggest, that one's the next biggest. But you also come away saying, this one is not that much smaller than that one. In fact, I can see from here that it's 20% smaller. Here, you would conclude that it's quite a bit smaller, and this is quite a bit smaller too. So this is just wrong. It's just misleading and wrong. So here are some examples of, so these are not labeled bad or ugly or any of those things. So Klaus Wilke likes these. I like these too, by the way. And so developing a visualization eye means looking at a chart like this and appreciating it for how the aesthetic and the sense that the designer had to communicate this. So this is talking about elections in Georgia have become more competitive over time. The share of Georgia voters who cast their ballots for Republicans and Democrats in the Senate, the governor, and the presidential elections, 1998 to 2022. So 1998 to 2022 is the years. Um, the red and the blue, they didn't have to label those because you know that red means Republican and blue means Democrat. And excuse me, 50% presumably is the, you know, equal amounts on either side. And so then they talk about how that's changed over time. And so if you read down on this chart, you notice how narrowly these have gone. So what's happened is the spread between these has really narrowed dramatically starting in 2020. So that was for the Senate. For the government, for the governor, it did a pretty similar thing. It was really close in 18, and then 2022 it was pretty close. And then in president, it got really close in 2020 was the last election. So this is a set of really effective charts, and not a lot of space. I'd argue that this is um, minimizing or sorry, maximizing the data ink ratio. It's done a really good job of that. Here's kind of an extension of that, and this is where Republicans did well. And so these are states, and the number is the percent that was more heavily for Republican versus Democratic. And so uh, yeah. So in Florida, this was 26 points leaned Republican. I'll just give the other example. Why do we have Florida here twice? Not sure why we have these states repeated. It must be between Florida and New York. I'm sorry. 28, 21, 16. Oh, those are years. No, those aren't years because I don't think we had. Anyway, not sure what the numbers mean here. I thought this was a pretty good visualization until I looked at it closely. Partisan lean between V plus 15 and R plus 15 in Florida and New York. Florida, Florida, Florida. These must be different counties. I'm going to guess maybe counties or maybe what says. Oh yeah, they're different districts. I'm sorry, different districts. It's one election, one point in time. So this district, the number is the district number. Finally, I got it. Okay, so Florida District 26 leans heavily Republican. Florida District 14 leans not as heavily, but pretty heavily Democratic. And so this chart does a pretty effective job of that. Um, okay. Okay, so let's talk about some examples of visualization I. And this is, Klaus Wilke labels this chart as bad. This is a stacked histogram. You've seen this before. So this is a histogram. This is showing a distribution. And it's a stacked histogram because the author wanted to show female and male. This is Titanic passengers. And so this is a count up here, histogram, remember, and this is the age. So these are age brackets. It goes from 0 to, I don't know what that is, 2 or something. Um, and the reason it's labeled bad, let's see, I think we go down here. Oh, let me go back here a minute. The reason it's labeled bad is because while you can tell how the age is distributed for men, you can't tell how it's distributed for women because the women don't start at a zero axis. So the problem is that if my task is to understand both how men and women, how the age distribution of men and women works, this chart doesn't work. So instead I say, well, okay, I will start both at zero. So I'll start both the men and the women at zero. This is also labeled bad, and it's because I think what's implying here is that the men are behind the women, which is fine if they always were, but they're not always. And so you have this problem where you have to have a different shade. Yeah, you have it. So in this case, whatever this age bracket is, there are more women than men. And so I had to use a different color for these guys where there are more. So it doesn't work. It's too much. It's too much work, too much cognitive load. Here's one way to accomplish that. This is an overlapping density plot. This does okay, right? So it's not labeled as bad or ugly or any of that. Um, the problem with this, so this is a histogram again still, right? The problem with this is that, as I mentioned earlier, it's hard for us to uh, understand the area under a curve. But probably that's not what we're trying to do. We're just trying to show density to the user. The task that we're trying to get them to take on is to show the relative age of the Titanic passengers. And so this does a pretty good job. You only have this really slight space where women outnumber men, and the rest of the time men outnumber women. And so I can put men behind women, and the overlaying works pretty well. Now, if I don't like that, what I can do is just separate these two out. And you notice I have the same y-axis on both charts, and so these work side by side. If I didn't have the same y-axis, I'd want to put them top to bottom, but I have male passengers, I have female passengers, and then I have all passengers. So I've added essentially a third grouping. So I want to know what percentage males are. I can see that. I want to know what percentage females are. I can see that. And I have the distribution here. So this works pretty good. This is an overlapping density plot where I separated the males from the females. Now, this chart is called an age pyramid, and this, in my opinion, works really effectively. So what you do is it's still a histogram, and zero is out here somewhere. And then what you do is you plot the sizes. You plot the male sizes on the left-hand side, and the female. This is not sizes, but count of on the right-hand side, and you put those side by side. So this, when you look at this, you want to enforce some symmetry on this, but it's not symmetrical, right? It's not only is it not symmetrical, but it's not the it's skewed. So this works pretty good. So we basically wrote two histograms. We rotated them 90 degrees, and we put bars at in one pointing in one direction and bars pointing in the other direction. Okay, now I want to talk some about chart junk. Here's a good example of chart junk. This whistle is superfluous. This is what is this? Fraud cases detected by private companies in private companies by method, and it's a percent. So if they detected fraud in an external audit, there it is, five of them. If they just detected it through something else, if they detected it through document examination, they did it. So this is chart junk. This whistle is chart junk. And frankly, using a pie chart for this, maybe I'm trying to show, I'm not really trying to show the specific percent. I'm trying to show what the whole is made up of. Maybe that works as a pie chart, but I'm not a big fan of pie charts. But excuse me, the whistle is superfluous, and as I look at it, it looks like it's angled, so it looks like it's kind of 3D going in that way. Not sure that is. I can't really. Oh no, that is. So this it's even worse because this is not a real circle. This is an oval. So the chart junk has introduced a distortion in the whole thing. So it's really it doesn't work. Okay, so this is I think the image that triggered a whole cascade of discussion about chart junk. And this is in the New Yorker. Sorry, it's in Time. Now, there's two competing sort of iconoclasts. One is Nigel Holmes, who thinks that you just want to communicate well, and one is Edward Tufte, who is this minimalist, and they're kind of at odds with each other. They have completely different opinions. So, excuse me, Nigel Holmes um, drew this chart, published it in Time, and it drew all kinds of comments from purists about what it's trying to tell. So it's intended as essentially a line chart, and it's talking about diamonds were a girl's best friend. So in 78 they were here and they rose up to whatever this is, 80,000, almost 80,000 in 1980. And then they started dropping off pretty precariously to where in 1982 they were 20,000. This is the average price of a 1 carat D flawless diamond. So if you Google chart junk, this chart very often comes up. And I'm going to argue that while this is chart junk, it might be very effective. And the point here is that you should really draw your chart adapted to the nature of your average reader. And if your average reader of Time magazine, I don't actually know who that is, but it's the general public, right? So your average reader of the general public isn't necessarily college educated, isn't necessarily versed on charting and visualization, and so you could argue that this actually works pretty effectively. So there's been a lot of discussion on this, and so this is total House and Senate campaign expenditures in millions over the years from 72 to 82. And it's up to 300 million in 82 estimated in at that. And this is drawn Edward Tufte style. So I've just the facts, ma'am. I've got just barely enough ink on here to communicate this. So this would be an Edward Tufte style chart. And here's another way to draw that using, frankly, chart junk. And so this is telling the same thing, monstrous cost, the total cost of House and Senate campaign expenditures, sorry, total House and Senate campaign expenditures in millions, and it's 300 million in 82 estimated and 82 here. So this is the same data. This is telling the same thing as this chart. And the question is, which is more effective? And the answer is, it depends on the nature of your average reader. So here they are side by side. And it's kind of this title is maybe reversed because Nigel Holmes would drew this chart, and Edward Tufte, I don't think he did draw this chart, but he would draw a chart that looked like this. If you followed the minimal ink principles, you'd end up with a chart like that. Same data, but you'd end up with a chart like that. And so the thing you ask yourself is which is more effective? Well, some people ask that. And so there's this study, the effect of visual embellishment on comprehension and memorability of charts. This link, if you download the slide, this link will take you to the actual study. And so what they did was they did recall tests. They took two different chart representations, and one group got this kind of chart, and one group got this kind of chart. And then they asked them to recall the subject, the categories, and the trend. And here's the really interesting thing about that. There were no significant differences in recall of the two different chart types after 5 minutes. So if they did this test and they asked them five minutes later, there was no significant delta in these two. However, if they went back to those participants 3 weeks later, recall was significantly better in Holmes style charts. That's these ones with the chart junk. So recall of this kind of chart was significantly better than recall of this kind of chart. And it kind of makes sense. Yeah, this is a memorable graphic. And so maybe I'm not that interested in the campaign expenditures. And so this chart, so the reason this chart sticks with me is because it's so visually arresting. Whereas this chart is kind of humdrum, and it's already a humdrum subject. I probably don't remember that much about it. Now, I'll mention that the study's been criticized for its methodology, and it had small sample size, and it had lack of, you know, cultural diversity, socioeconomic diversity of the subject. However, it's a pretty kind of compelling thought. So here are the things that they did between these two. So they compared this one, Nigel Holmes versus Edward Tufte style chart. So these are telling the same thing. It's the same data. And so you ask yourself, well, you saw which of these, which is more memorable? This one's a little hard to kind of sort through. So that's a little more difficult. You have to spend time on this to understand what this is saying, to understand that this line is the actual chart, not this leg that, shoots off in this direction. Here's another one. These are the ones that they use. So they use one like this on the left. This is where the cosmetic dollar goes, manufacturing versus retailing. And here it is in a in a bar chart, excuse me, a bar chart. Now this is hard to read. Presumably the subject saw something that was easier to read, but this is just a flat, bar chart. Here's another. Oh, actually, let me just back up here a minute. So I like this touch where they say manufacturing, retailer, and 8 cents went into ingredients. So I assume it's this red. Oh, here it is, right here. This red outline right here was ingredients. So pretty effective call out. And if you're trying to get somebody's attention, here's another one. This is about employment costs of a steel worker per hour in the U.S., Germany, West Germany, France, Japan, Britain, and South Korea. So this is clearly just junk art. Just putting this up here just draws your attention to it, but that's about it. Uh, I'm not sure what the significance of the red is. I mean, I understand what the graph is doing, but I'm not sure why they painted it red other than call your attention to it and to get it kind of symmetrical with the guy's helmet here and the color style. Here's the Edward Tufte style of that chart. Very minimalist. Here's the US, here's Germany. So you ask yourself, which is more effective? I might argue that this one is in this particular case. This one is poorly rendered in the reproduction. I'm not sure it was actually that bad, but this is the rise in cigarette prices from hard to read 78 to 82, and here it is in a Edward Tufte style chart. So uh, so the bottom line is that for the general public, these kind of charts with a lot of chart junk in them, they improve recall after 3 weeks. That doesn't mean you should use them. So I think that most of you will be using these kind of visualizations in a business environment, and they're mostly, my opinion, not appropriate in a business environment. Now, if you end up in media and you end up as a journalist, you might very well use them. But if you end up in most other businesses, that style of um, visualization is not really not effective. It distracts too much and it makes you look like an amateur, frankly. It's like using 3D. So a visual design is good if it communicates a lot with little. I really like that. I really like that statement. This is Edward Tufte again. Let me say that again. A visual design is good if it communicates a lot with a little. And that's well said. If I can communicate a lot with a little bit of ink, that's a good visual design. And so you get to these principles of graphical excellence. Well-designed presentation of interesting data, substance, statistics, and design. So these three things kind of go into a well-designed presentation. You can communicate complex ideas with clarity, precision, and efficiency. And you give the reader the greatest number of ideas in the shortest time with the least ink in the smallest space. So if you can put charts together that kind of follow these principles, you're going to win. Okay, in this chapter, we covered pre-attentive color, pre-attentive attributes, color, form, spatial positioning, and movement. We actually spent almost no time on movement. And the idea was to direct attention in data visualization. We learned about Gestalt principles, similarity, proximity, enclosure, and connection. And this is really about grouping. Excuse me. We learned various data visualization strategies that minimize the data ink ratio. They minimize the eye travel, and how to choose an effective font depending on what you're trying to do. And then some common mistakes in visualization, such as choosing the wrong type of visualization, not using the right type of chart. In other words, trying to display too much, trying to do too much in one chart, and basically using the default format in Excel. So Excel will draw you a chart. You need to go in afterwards and fix it up. Sometimes that's, just small changes. Sometimes that's more involved changes, and your textbook has quite a bit of techniques for how to go about that. But you want to plan on doing that. Just because Excel drew you a chart doesn't mean that's the chart you're going to use. You want to plan on doing that. Okay, now I'm going to switch gears to dashboard. And the reason I'm doing this, we have actually we have a the final lecture of the of this course is about dashboards. But I want to give you a dashboard overview because next week you need to show me your data for your dashboard. So you don't have to build your dashboard. All you have to do is load it into Tableau and show me that you've loaded it there. And so if you're not clear on what a dashboard is, I wanted to give you a sense of that. And whenever I start on dashboards, I always want you to keep this principle in mind. Just because you can do something doesn't mean you should. And so when you start interacting with Tableau, you can find out you can do a huge number of things, a huge number of different visualizations. And just because you can do them doesn't mean you should. The trick to Tableau is to figure out what the most effective visualization is, not to pile as many as you possibly can into a dashboard and say, I'm good for today. So, and having said that, I think my personal opinion is that a lot of these dashboards that we're going to look at, they try to do too much. Anyway, let's take a look at them. Uh, okay, and so you can go to this dashboard showcase, and you can see a lot of these. And I just want to bring up a few of these. Let's see, let me do this. We'll come back to the Superstore. Every time you come here, these are different. These generally. Let's take a look at the profitability and shipping KPIs. Okay, so since we're here, I need to explain KPIs. KPI, key performance, I'm sorry, key process indicator. And the, excuse me, the idea of KPI is that it's the one measure that uh, an operational group should pay attention to. Now, KPIs have been wildly overused, and I think you really should keep uh, uh, straight in mind what a KPI really means. It means, for it doesn't matter who the person is, whether they're a receptionist on the phone or they're somebody driving a truck or somebody working in a warehouse or wherever. KPI is the one thing that they should think about in their day-to-day operations to making better. And so let's take the example of a help desk, a call-in center where I have customers call and they need help from technicians with my product. And so I could say, I could design a KPI where I want to minimize the amount of time that my reps are on the phone with customers. I want them to be as efficient as they possibly can, and to get the customer off the phone as quickly as possible. And so I could design a KPI that measured on a even a minute by minute basis because I have a phone system that's monitoring, that's keeping track of the incoming calls and how long they last and all that kind of stuff. And so I could have a KPI system that was continuously updating that was telling me what the average time spent on a call. Maybe I have, a dozen customer service reps in the call center at a time. And so this KPI is just continuously monitoring how long calls are taking. And maybe I have a display board somewhere where it says, your average call time right now is 5 minutes, or it's, 4.7 minutes or something. And I might have a goal, to get it to 4.5 minutes or something like that. So the point of it is that you want people in operational positions when you use them this way to think about that KPI and everything they do. So you want that customer service rep to be thinking about how fast can they resolve this customer's problem. Now, poorly designed KPIs can really backfire, and that's a good example of one that could really backfire, right? You could have, I've experienced this, you probably have too. I've experienced reps who I know for a fact are on a KPI around minimizing, on time call with the customer because they can't wait to get you off the phone, right? So that actually sends a bad message to your customers, and so that's probably not a well-designed KPI. Maybe it minimizes costs for the company, but it's really a poorly designed KPI relative to customer service. So you might instead set a KPI of minimizing wait time. So you can spend as long as you want on the phone with a customer, but we want to minimize the amount of time that they're waiting for a rep to come along. Now, the reps don't have much to do with that. Well, they can, they could linger on the phone for a long time. But in general, that has a lot more to do with staffing load and that sort of thing. My point is just that KPIs there should be a small number of KPIs, like one or a small handful of KPIs, and they're the process measure that tells you how effective this organization uh, is operating. Okay, so this particular one is about KPIs, and it's shipping KPIs. And so what I've got is the shipment delay in hours, and up here I have the pay amount, and blue is good, orange is okay, and red is bad. And so this is delay by company. So this is probably a shipping organization that has a bunch of company clients. And so each one of these company clients is represented up here. I'm not sure why there's so many dots here, but and the idea is that I could pick one of these, presumably, and I could just highlight their data. And that's what Tableau does really well. So you notice I clicked on accent on style and I got all these. So I see that I'm doing really poorly with accent on style. Whereas if I come up here and I pick HP as an example, I'm doing pretty good on HP. And if I come down here to somebody that I'm doing pretty well on, I do better on it. In fact, I do it across the board, which is suspicious to me. You tell me every shipment is on time for this customer, and there's so many that are, that's just very suspicious to me. But this is probably fictitious data anyway. So that's the idea of a KPI. In this case, the user can choose this and it changes the display that I have. Let's just take a look at what else we have here. We have, so when I pick Value Mart as an example, uh, what do I still have accent on style here? Oh, I choose them here. Sorry. If I pick, well, somehow I should be able to pick Value Mart here. And then I have the shipper. And then here's the origin state, here's the destination, here's the pay amount, so on and so forth. So this is telling me a bunch of stuff, a bunch of information about where it was shipped from and to and how much the pay amount was and that sort of thing. This is probably real interesting to me if I'm in shipping. It's not very interesting to me right now. So that was a relatively simple dashboard. And presumably it's excuse me, really important to the manager of this department, because he wants to know how well he's servicing customers. So this one actually has two tabs. Let's see what the probability KPI is. Okay, so this is the probability uh, this is the profit ratio. So this is how much money they made on each shipment. I'm not sure why they call that probability, because this is actually the profit ratio. And so once again, I have my different companies. And so I can see how profitable my shipments are to for accent on style, anywhere from minus 100 to plus almost 700, 725, say. So that's the idea. That's a reasonable KPI. Let's go back. Let's take a look at another one. Um, how about mapping earthquakes in Japan? Okay, so I have, excuse me, this is where the Japanese earthquakes had happened. It looked like a lot of them happen offshore. And what this lets me do is with a slider choose the date range. So this is right now going from 3/9/2011 to 3/16/2011. Oh, there were that many in just that time frame? Oh no, this top thing wasn't right. there were that many in. See, I'm not convinced at all. Maybe this is showing all of them. Oh, that's what it is. This is showing all of them in this, whatever the date range is. And this slider is adjusting the magnitudes according to, where I am. So if I change that slider, it's how this magnitude, this is a histogram, right? The, excuse me, this is changing the histogram of what I'm seeing of the earthquake magnitudes. And it looks like I can highlight a particular magnitude. So I'd only like to see the 5.5. So I do that. I can highlight a region. Maybe I want off East Coast, or maybe I just want East Coast region. Oh, there we go. So now this is reducing down. So we're doing gray point with, I think, everything selected, and then a darker grays with the one that's actually specifically selected. And then the depth, this is not a slider. This is just telling me how deep, presumably in the ocean, I guess it could be on land too, the particular earthquake happened. And if I scroll down on this, now in general, you want to avoid scrolling in dashboards. The idea of a dashboard is it shows you in one screen everything that's going on. This is showing me the magnitude quakes. This is showing me the date, the time. Presumably, these are, let's see, adjusting. Yeah, these are adjusting according to my picks up here. And you notice what they've done is they've actually showed everything in gray, but they highlight the ones that I have picked. So hopefully that gives you an idea of what a dashboard is. Dashboards are a synopsis. They can have many different visualizations. Actually, let me just go back for a minute. Find one that has. Let's take a look at pediatrics overview. Okay, here's one. So you notice this has a bunch of different chart types on it. In general, if you're showing different data, you want to use a different chart type. So I'm going to commend the people who wrote this pediatric overview for that. It still looks like it's refreshing, but what I've got is the encounters by department. I've got a horizontal bar chart here. I've got a big bold text, number of admissions, number of discharges. You could say this is a KPI. It's not really a KPI. It's just a key metric, number of admissions, number of discharges, percent patients LWOBS. I'm not sure what that stands for. This is a percent, and this is an average hospital LOS, length of stay. I would guess that's what that is in bed days. And so here's the number of encounters. Here's how many were urgent. Here's how many were elective. Here's how many were emergency. Here it is in clusters by, I'm not sure what, patient visits and length of stay. And here's a bubble chart on patient visits of length of stay. Here's the number of days. Here's the number of visits. So this is excuse me, this is a histogram. I've got average hospital days here, and this is an account. And then I've color coded those by these clusters. 1, 2, 3, 4. I'm not sure what those clusters mean, but I've color coded those by that now. This particular dashboard doesn't have anything that the user can select that I can see. So this is just showing me where we are right now. And so presumably this dashboard is updated maybe every day, maybe every hour, probably not every hour, but maybe every day, so that at any point the chief of the pediatrics department brings this up and says, okay, where are we today? What do we got? It might be useful to show me a change in trends or something like that. But this is a dashboard that's showing me a static point in time. By the way, your dashboard will probably do that, although you can have it select different things if you want. But your dashboard for your term project will probably do something like this. Use different graphing techniques. And you notice they're not just doing this because they wanted different graphing techniques. They're using them because they're doing them because they felt like the designer felt like that was the best way to visually represent what they were trying to convey. Okay, so hopefully you have a good sense of what a dashboard is. You can go to this site and you can see all kinds of different dashboards if you want to see some. And then I want you to keep firmly in mind this idea that just because you can do something doesn't mean you should. Now, we're going to switch over into an introduction to Tableau. So one of the things you should have is you should have Tableau loaded. And I'm going to walk through just an overview this week so that just familiarize you with various aspects of Tableau in the next lecture. So I will see you next time.